Some of the most difficult parts of this chapter is really interpreting the question, and I do realize that. So we're going to work a few more together. So let's look at this one. The reaction, and they give you the balanced chemical equation, has an enthalpy change of negative 65.2 kilojoules, now be careful, per mole of calcium hydroxide formed. In this instance, there happens to be a 1 in front of calcium hydroxide on the product side of the balanced chemical equation. What I need you to understand is that this allows you to write the relationship negative 65.2 kilojoules per 1 mole, because this is what it says, of the calcium hydroxide. If you were doing a reaction where it said exactly the same thing on this over here, but in the balanced chemical equation there was something other than a 1 in front of it, then you better be careful when you use it in the equation that you're multiplying up by whatever factor you need to. So just be careful. This is the relationship it's giving you. This is the relationship you get to use, period. All right, so it says when an enthalpy change in kilojoules, what is the enthalpy change, in kilojoules, when 500 grams of calcium oxide reacts. So we're going to start with calcium oxide as being the thing we know something about. 500.0 grams of calcium oxide, and that is the reactant. So it's telling us how much of this that's going in, and it wants to know heat coming out. So because the relationship they gave us was per 1 mole of calcium hydroxide, and that it is a 1 in the equation, then I know that it's also that amount of heat for every 1 mole of water and for every 1 mole of calcium oxide. So I can go from grams to moles of calcium oxide. Just with the periodic table to get myself to moles. If you add that up, it'll be 56.08. Now that I know moles of calcium oxide, I can look at my balanced equation and I can say for every 1 mole of calcium oxide that goes in, the heat change is negative 65.2 kilojoules. So that will allow me to say that there's a negative 581 kilojoules involved when 500 grams of calcium oxide reacts in that reaction. So I take 500 grams calcium oxide, let it react with water to make calcium hydroxide. It will, is that a produce or absorb? It's a negative sign. What do you think? If it's a negative, what does that mean? That means it's exothermic. So be careful. They could be asking you, in the choices here, it could say absorbs this much, releases this much, or loses this much, and it may mix that up. And you're going to need to be able to understand that that negative means it loses, as in releases it to its surroundings, which means if you were holding it in your hand, you would feel that heat being released by the reaction to your hand, and your hand would get hotter. Okay, so a question that comes up, if you're in my class currently, then we're using an online learning system called Newton. And there's a problem within your Newton. I can't remember if I pulled it from the quiz or if I pulled it just from the practice problems. But it looks very similar to this, yet it is not at all the same. So this is an example problem pulled from Newton. And then when we read it and we go to work it, it is similar, but you just got to be careful. It's the ratio thing I talked about up here. Here's where that sort of issue comes in. So it gives you the balanced chemical equation here. It says when 1.75 grams of N2 reacts with excess H2 by the equation, 10.5 kilojoules of heat are absorbed. What is the enthalpy change of the reaction per mole of nitrogen gas? Okay, so what it's telling you based on this use this information. It says when this much nitrogen reacts, this is the heat absorbed. So write that relationship out properly. 1.75 grams of N2 into the reaction. There will also be 10.5 kilojoules absorbed into the reaction. Now it's absorbed, right? So that is a positive sign. Again, I'm going to put the positive to stress that I thought about it. Because if it had said released, you've got to put a negative right there. So now this is the relationship I have to work this problem. And it wants the enthalpy change per mole of nitrogen gas. Well, if you look at what you have energy change per gram of nitrogen. Turn that upside down, maybe it'll look different. You can invert this and say, put the positive 10.5 kilojoules on the top. So there's your enthalpy change per 1.75 grams of N2, and they want per 1 mole of N2. So this problem is really nothing more than a gram to mole conversion. So you're going to take that relationship and then you're going to change from grams of N2. Notice I put it on the top because I need it to cancel, because I need moles of N2 on the bottom. So this is kind of weird, kind of different, but now that you've done mole math long enough, I hope this isn't just making you nuts. So we want heat on the top where it is, and that's good. And in the bottom, we need moles, not grams. So we put grams on the top here, so it'll cancel the grams of N2 currently on the bottom. And we will get per mole once we do this. So go to the periodic table, add up the formula weight for N2. That's 28.02. So grams of N2 cancels. You're going to get kilojoules per mole of N2, which is exactly what they asked for. Enthalpy change, which is kilojoules per mole of N2. So that's how you work this one. If you plug and chug through that correctly, you will get 168 kilojoules per mole of N2.